Okay, so today we're going to look at angles of any magnitude. Our learning intention is the knowledge of what the unit circle is in terms of the trigonometry and how this unit circle kind of creates the trigonometric graphs. From here, we're going to determine that there are multiple solutions to angles. There are the acute version and the obtuse versions. So we'll be successful if we know where each quadrant or section of the graph is positive or negative and correctly calculate possible angle solutions. So let's look at our trigonometric graphs. So we've got sine, cosine, and tangent. So if you were to plug in, so what I have done, okay, so let's say this is 90 degrees. So this is the first quadrant, then 180, the second quadrant, 270 is the third quadrant, and 360 is the fourth quadrant. Yeah, so angles are from 0 to 90. This is going to be the first quadrant. Angles from 90 to 180 is the second quadrant. Um, 180 to 270, that's the third quadrant. .270, 360 is the fourth quadrant. So if you were to plug in to your calculator, if you were to do sine 0, we would get the answer of, sine 0, we get the answer of 0. Yeah. If we press sine 45, we would get the answer of 0.7. We press sine 90, we get solution of 1. And just let's do the main points. Sine 180, we get 0. Sine 270, we get -1. And sine 360, we get 0. Yeah. Now, these waves or these curves continue on indefinitely. Yeah. They are periodic. So this is one period of one revolution of 360, but the curve keeps going, and you can have negative angles as well. Yeah, so the curve is continuous. Same thing, if we had cosine, if you got your calculator out and you went cos of 0, which I did first, right, we realize that's 1. So cos of 90, we get 0. Cos of 180, we get -1. Cos 270 is 0, and cos 360 we get 1. Tangents are different, yeah? So if we get tan of 0, we get 0. If I get tan of, let's say, 89, I get 57. Yeah, quite a large number. But if I press tan of 90, I get a math error. And I'll explain why that happens. Let's just go tan 91. We get -57. If we go tan 180, we get 0. Tan, let's say 269, we get 57. But tan of 270, we get a math error. So this wave has a lot of asymptotes. And what it does, it comes from the unit circle. So say that imagine we had a circle with the radius of 1 unit. Yeah. Then if I wanted to calculate this angle here and I made a right angle triangle, so in this case it would be here. Yep. And so what I would calculate would be that if I wanted to calculate cos, well, cos would be the x-coordinate, so this side, so x-coordinate, which is here, because that's going to be the adjacent over the hypotenuse of 1 unit. So my x-coordinates can be considered as my cos x, which means that my y-coordinate can be considered my sine x. And so if I would have, say for example, if I had a very small, minuscule right angle triangle, yeah, and let's say that to the point that it was almost imaginary 1 whole unit in length, and a height of imaginary 0, but still with the hypotenuse being 1. So if we had cos of 1 over 1, we get 0. So cos of 0, or we get 1. Yeah. And obviously if we go really tall, we had a triangle here, we would have, you know, sine of nearly 1 over 0, so which that would be tan. So tan of, let's say, so what's 1 divided by 0? Well, that's an undefined solution, which is so why we get tan of 90, because it's up here at 90, we get a math error. Yeah, because we can't calculate this very thin triangle here. Okay, so this is how these kind of triangles calculate these waves. So the same thing, if I go over here, if I went over to this side, I'm actually measuring this angle, starting here at x is 0. Okay, so you may, basically with angles of any magnitude, we have this acronym ASTC. Some spell it as CAST, so cast, because it's one way to remember it. But we tend to use the acronym or the mnemonic all stations to central. So ASTC, all stations to central. It means that in the first quadrant, sine, cosine, and tangent are all positive. So here, all trigonometric ratios will be positive. Between 90 and 180, so in the second quadrant, we can see that sine is positive, sine is above 0, but cosine and tangent are both negative. So here, only sine is positive. In the third quadrant, we have sine as negative, we have cosine as negative, but the tangent is positive. So we have only the tangent is positive. And in the fourth quadrant, we have sine is negative, cosine is positive, but tan is negative. So only cos or cosine is positive. And so all stations to central reminds us that we go all being positive, only sine being positive, sine for station, 2 tangent being positive, and central cosine being positive. Okay. Now, what you can see is I've also written in the radians. So if you know what radians are, I've written what the radians. So 360 would be 2 pi, 180 would be pi, 90 would be pi on 2, 270 is 3 pi on 2, 45 is pi over 4, and then we got 115, so 135 is 3 pi on 4, 225 is 5 pi on 4, and 315 is 7 pi on 4. So if I have these, please note that so this is from 0 to 90, that's all good. To find this angle, it's actually 180 minus your theta. Or if you're doing radians, pi minus theta. If you're working in this quadrant, we have 180 plus theta. And if we're working at the fourth quadrant, we've got 360 minus theta. Okay, and we obviously can have negative angles because, as I said, these waves still continue on. Okay, let's do some questions, some examples. Before we do examples, let's talk about exact triangles. Say, for example, I made a right angle triangle with an isosceles version where the base and the height is 1 unit. Using Pythagoras, the hypotenuse is going to be square root 2. If this is an isosceles triangle, then the base angles have to be the same, and in order for that to occur, this needs to be 45 degrees. Okay. Looking back, converting 45 degrees into radians, we know that it will be pi over 4. We do it in radians. Now, say that I have an equilateral triangle. It's not a great scale, but I had an equilateral triangle where all the sides were 2 units. Equilateral triangles have a base unit of 60. So if I was to cut it in half, I would have still the hypotenuse being 2, but because I've cut this angle in half, or cut the triangle in half, that means that this angle up here is only 30. The base becomes 1 unit because 2 divided by 2 is just 1. And so the other length is going to be square root 3, because 2 squared minus 1 squared is square root 3. Okay, using Pythagoras' theorem. So to convert it between degrees into radians, so we could go 60 times pi over 180. That's for this part here. And that works out to be pi on 3. And then 30 times pi over 180 is pi on 6. Okay. And we'll need that to do some problems later on. Okay. Here's some examples. We want to find all the quadrants where sine theta is less than 0. So we want to see which quadrants is sine theta less than 0. So if this is our sine curve, where is it less than 0? What's going to be happening in the third and fourth quadrant to central. So that's going to be the third and fourth quadrant. B, where is cos greater than 0? Well, cos is greater than 0 here between 0 and 90, and from 270 and 360. So this is the first and the fourth quadrant. So it's positive in these quadrants here, the first and fourth quadrant. Second part, we're going to have two parts of the section. So we're going, where is tan theta less than 0? Well, tan theta is less than 0 here in the second quadrant and in the fourth quadrant. So we'll just say second and fourth quadrant. Where is cos greater than 0? So similar here, we figured out it's going to be first and fourth quadrant. So the question is saying what quadrant satisfies both tan being less than 0 and cos being greater than 0? And in this case, it's only going to happen in the fourth quadrant. Okay. All right. We want to simplify. Where is cos 360 minus theta? So where is 360 minus theta? So 360 minus theta is this quadrant here, and cos is going to be positive. So cos theta is greater than 0, or it's going to be positive. What happens when tan is 180 minus theta? So 180 minus theta is the second quadrant. Well, tan in this point is going to be negative because the only thing that's positive in this quadrant is sine. So tan theta is going to be less than 0. It's going to be negative. So we're jumping from degrees into radians. So pi means 180. Where is cos going to be 180 plus theta, or 180 plus x, or pi plus x? Well, that happens in this quadrant here. And the only thing that's positive in this quadrant is tangent. So cos x is going to be less than 0. It's going to be negative. Here it says, where is sine going to be 2 pi minus x? Well, 2 pi is 360. I'm going to minus a degree, minus a measurement. So 2 pi minus x is happening in the fourth quadrant. And sine is negative here because only cosine is positive. So sine x is going to be less than 0. It's going to be negative. Okay. So we want to find the exact values of tan 225. So how I do this is I will create my little intercepts, quadrants. Tan 225, it starts here at 0, would be somewhere here. Okay, and what I do is try to make a right angle triangle, and then I think, well, 225, because this is 180 plus theta, I'm going to minus 180 from it. And I calculate that this angle here is now 45 degrees. And so what I do is I actually know that that's very similar. That is exactly the same as my exact triangles. I get of unit of 1, 1, hypotenuse of square root 2. Yeah? And so looking at this, I want to calculate tan of this. So tan is going to be opposite over adjacent. And in this case, it's going to be 1 over 1. So 1 over 1, which is just 1. And so therefore, the solutions to this of tan 225 is going to be a positive 1, because all stations 2, tan is positive here. And you can check it by going tan 225 we get a solution of 1. Okay. Let's do the next one. We got cos of 120. So 120 is somewhere here. These triangles happen at this point. So I do, this quadrant's 180 minus theta, and at the moment theta is 120, so that's going to be 60 degrees. Okay. I look at my exact triangles. Yeah. 60 degrees opposite the square root of 3. It's got 1 down here and 2 there. Okay. So we want the cos of this, and cos is going to be adjacent over hypotenuse. So cos theta is adjacent over hypotenuse. In this case, it's going to be 1 over 2. And this quadrant, cos is negative. So it's going to be negative a half. We can test it. Cos of 120 is negative a half. Okay. We've got some examples using radians. Okay. So this is 2 pi. If I do a full revolution, here is pi. This is pi over 2. Yeah, so we want sine of 90, basically. That's what we're trying to find, sine of 90. Well, looking back at our graph, sine of 90 equals 1. Yeah. So the solution to here is 1. So sine of 90 is 1. Now, obviously, if you were into radians, to go into radians, go to press Shift Mode 4, and we'll go sine Shift pi over 2 to get the solution of 1. Yeah. So you need to be confident in going from degrees into radians and back. Okay, let's look at the next part. We've got 2 pi over 3. Okay. We can convert, if we like to convert 2 pi on 3, we times it by 180 over pi. So 2/3 times 180 is 120. So it's cos of 120, so it's back over here again. And we've done cos of 120. So our solution, same solution, is negative a half. Okay. All right. Some more examples. All right, so here are examples where the revolutions are either negative or a full revolution plus a bit more. Okay. So what I'll do is I'll quickly just draw up my coordinates. Okay. So this one is saying cos of 570. So we've got a degree of 570. So we go around whole way once. So we've got 570 minus 360. That's a full revolution. And now I've got 210 left. So that's going to be somewhere here. Okay. So 210 minus 180, I get an angle of 30. Okay. Now it is in the third quadrant, so it's going, the solution is going to be negative. Okay. And using my exact triangles, I want to find what cos of 30 is. Cos of 30 is adjacent over hypotenuse, so it's going to be square root 3 over 2. So square root 3 over 2, and the solution is going to be negative because it's in the third quadrant. You can always test it going cos of 570. It's a negative solution, and if you want that, we get square root 3 divided by 2. So where the error is coming from is because I'm in radians. So I'm going to go back to degrees. Yep, so cos of 570. Yep, and as we can tell, negative square root 3 divided by 2 is the same. Yep. So make sure obviously we're in degrees, so our calculator has to be in degree mode as well. All right, so now this is cos of minus 210. So starting here at 0, we're going to go backwards. This is 100, so this is negative 45, negative 90, negative 100, negative 120, negative 180, negative 200, negative 210, somewhere here. Yeah, and so remember this is we're going backwards, so all of a sudden this becomes 30 degrees here. Yeah, so still working with 180 things, right? So we're going to make a triangle here. Same thing, so we want to find what cos of 30 is. It is actually going to be negative in this quadrant. Yeah, so the same, it's going to be the same solution. Negative square root 3 over 2. We can check cos negative 210 square root 3 over 2. Okay. All right. So now we've got sine 13 pi over 6. So 13 over 6 times 180. That's equivalent to 390. Okay. So we do a full revolution of 360. And then we have 30 degrees. But instead of, because we're in pi's, and so because we're in radians, 30 degrees in radians pi on 6. And I want the sine of that. So sine of pi on 6 is the opposite over the hypotenuse. So pi on 6 is here. So the opposite is 1 over the hypotenuse. So it's going to be a half. Sine is positive because all sine, cosine, and tangent, all trig functions or trig ratios are positive in this quadrant. So that's the solution for that one. So now this is tan of negative pi on 2. So that's this negative 90. So I start here at 0. I'm going this way to tan of negative pi on 2. And we know that when it's here and here, it is undefined. And your calculator will pop up with a math error. So we're in degrees. So what I'll do is I will press tan of negative 90 and not pi on 2. The reason why I would do that is because if I did pi on 2, I'd get something, yeah, and I need to be in radian mode in order to get this correct solution. Okay. All right. So continuing on, we've got if theta, cos of theta is 3/5 and sine is negative. So we want to know where cos is positive. So cos is positive in the first quadrant and the second quadrant, but sine is negative. So we want sine is positive here and here, so sine is negative here and here. So we actually are looking at this quadrant, the fourth quadrant. So if I make a triangle like this, okay, I'm looking at this angle here. Let's call it x. So cos of this angle, theta, so if we called it theta, right? is 3 over 5. So that means this adjacent over hypotenuse. So using Pythagoras, I can figure out that this side here is going to be 4 units. All right. It wants us to now find the value of tan theta. Well, tan theta in this case is opposite over adjacent. In this sense, it's going to be 4 over 3, opposite over adjacent. And tan is negative in this quadrant, so that's our solution, negative 4 over 3. Okay. All right, let's look at this one. We want, given that sine is 4/7, so all stations to central. So sine is positive, so that happens here and here. We want tan is negative, so tan's positive here, so tan and here, so tan's going to be negative here and here. So this one has two ticks, so we're looking at the second quadrant. Okay, so I draw my triangle. Okay, this is x or theta. Okay, it says it is 4 over 7. So this is sine, so it's opposite over hypotenuse. Okay, so using Pythagoras, I've got 7 squared minus 4 squared gives me square root 33. Okay, we want to calculate the exact values for cos theta. So cos is adjacent over hypotenuse, and in this case, cos is theta is square root 33 over 7. And that's as far as we're going to get to. That's close enough, okay? If we want to find tan theta, and the reason why that's close enough is because that's a rational number, right? If we want to find tan theta, well, that's opposite over adjacent. Okay, in this case, I'm going to rationalize the denominator. Okay, and that's that answer for that. Okay, all right. We want to solve for 0, where x is going to be between 0 and 2 pi, if sine of x equals negative 3 on 2. Okay, and we should remember that 3 on 2 is 3 on 2, so we're looking at a sine opposite over hypotenuse. We're looking at 60 degrees, but it's going to be a right angle triangle. It's going to be an exact angle. All right. The first part is I'm going to get approximately 2 solutions for this. Well, I'm going to get 2 solutions for this because I'm going to do a full revolution. So I look at it and go, where is sine negative? So it's down here. Sine is negative in this quadrant. And it's also negative in this quadrant. Okay, so we said it's going to be 60 degrees. We're in radians, so we're going to let's use the radians, right? So we've got, it's 60 degrees, so it's pi on 3. Yeah, and it's also here pi on 3. So remember that this area here is pi plus x, and this is going to be 2 pi minus x. Okay, and the reason is because we want to find the angle that happens between 0 and a full revolution. And it actually, and this solution happens twice. It happens here when it's going to be pi plus 60, which is pi on 3. So the solution for this part is so it's going to be 4 pi on 3. So if we multiply this by 3, so 4 pi on 3. And here it's going to be 2 pi minus pi on 3. So 6 pi minus 1 pi is 5 pi on 3. Now, obviously, if we did it in degrees, yeah, so we said that it was 60. 180 plus 60 is 240. And it's going to happen at 360 minus 60, so it's going to happen at 300. So negative square root 3 over 2 is that number there. So if I press sine 240, I get the same number. If I press sine 300, I get the same number. Now let's say, as an extension, let's say I was between 0, x, and 4 pi. Yeah, that means I've gone 2 revolutions. Well, it will still happen, the solution will still happen, at 4 pi on 3, 5 pi on 3, but then we're doing 2 revolutions, so it's also going to happen here again. So if this was 2 pi, that now becomes 4 pi, and this becomes 2 pi. So the next solutions would be 2 pi plus pi on 3 and 4 pi minus pi on 3. So we're going to get 7 pi on 3 and 11 pi on 3. Okay, and so that's the solution for if I had a range between 0 and 4 pi. So be careful with those. Obviously, if we're going backwards, you can have negative ones as well. Where we got this, where we try to find out what the answer was, we had to use our exact triangles. We went, what is opposite over hypotenuse? So opposite over hypotenuse is sine 60. In pi term, it's pi on 3, and that's where we got that. Okay, and that's it. Thank you very much. Bye.